Okay, today we're doing a little bit of review, and these are 5 things you should know how to do by now. And I would suggest you break this 8, and if you can factor it, you should. 2 times 4, and then the 2's will cancel. All right, right there, my answer is already different than I know some of yours because I looked at some of your answers. All right, some of you didn't have a 4 on the bottom, but the answer will have a 4 on the bottom. There, I've taken care of the numbers. Now let's take care of the A's. Do you get some of those A's aren't happy where they are? That's a way to think of it. These A's are not happy. There's negative in their exponent. So if you bring them down to the other side, then they'll be happier. And then a to the third will be right next to an a to the fifth. And when you have an a to the third and an a to the fifth, or sorry, a to the second and an a to the third, it makes an a to the fifth. How many of you had an a to the fifth on the bottom like that? Good. And the last is the B's. Well, think of it this way. This is like a B and this is like a BBB. And that cancels that. So there's b squared still on the bottom. But wait, there's nothing on top. Can you just leave a nothing? No, you have to put a 1. There's your final answer for the first one. Got a lot of little twists and turns, but I bet a lot of people got it right. Raise your hand if you got that one right. Okay, good. On to the next one. Very common answer is to go, oh, it's to the 0 power. Anything to 0 power is 1. And it's wrong. Why is that not 1? Because only the B is to the 0. Is the A to the 0? No, it's not. The A is to the 1. What's the 21? 2. It's to a first power. Those aren't zeros, so those are still around. That's gone. That part was 1. But these other ones are still here, so it's 21A is your final answer. It's kind of a trick question. All right, on to the next one. 4 to the negative 1/2 power. I like to think of this as 3 things. First, I take the root. Square root of 4 is 2. Then I put it to the first power. Well, 2 to the first power is still 2. And the last thing is flip it. And how do you flip a 2? Well, a 2 is really a 2 over 1, and then I flip it, and it becomes 1/2. Who had 1/2 for C? Good. Who's still in the running for 5 out of 5? Quite a few of you. All right. Now we come to the more difficult ones. This one, I need to find a base that this could be, that this also could be. What base could they both have? A 3. And this would be 3 to the third, and this would be 3 to the second. And now the bases can cancel. And they really aren't canceling, but it's kind of like they're canceling. And that is what's left with an equals. So 3x minus 1 equals 2, right? No, you got to be careful with that 3 distributing 3x and negative 3. Got to distribute this 3 here. A little 3 is hard to read now. To both parts. And then when you add 3 to both sides, you have 3x equals 5, x equals 5/3. Who's still perfect? And it comes down to the last one. We're down to 6 people that have a chance. On E is an elephantiasis. So that is saying, find the 5th root of 32, which is 2. And then you put it to that power, which makes it 2 to the 2, which is 4. And then this last little negative just makes it flip 1/4. Who did get the 5 out of 5? 1, 2, 3, 4, 5, 6 of you. Nice job. Maybe even 7. All right. Now, don't expect all of you. I get a few of you would make some mistakes. But if you were getting lots wrong there, then that's a sign you need to be coming in and get some extra help. What days am I available? Mondays. Wednesdays during what? And then Thursdays. And then also, just so you know, there is that math center. It's kind of like the writing center. There is a math center. It's open on Tuesdays and Wednesdays. So those are 2 mornings that I don't normally help kids. Tuesdays and Wednesdays. That's why we put the math center in on those 2 days, because math teachers aren't available in the mornings on Tuesdays and Wednesdays. I'm here for math, but not in the morning, like the true morning from 7 to 8. So that help center is really good. The guy who's in there, his name is Jim Lees. He's a tutor who hires out outside the district, and he has tons of kids that hire him to do tutoring for math. So he knows math really well, all the way up through calculus. And he's really nice. And if you just walk in there, if he's working with somebody, you give him a minute, he'll come over and help you. And there's also NHS students in there. And if some of you are picturing, I could actually be one of those tutors in there. They actually need people who are willing to tutor. And they wouldn't ask you to tutor anything that's higher than what you're in. You know what I mean? You're in honors higher algebra, right? But what if a kid in regular higher algebra came in? You could probably help them, right? Or a kid in lower than that. Like, there's a lot of classes lower than this. You may not realize it. There's geometry. There's regular algebra. There's algebra of lines. And I think there's another one that's before that. So anyway, there's a bunch of algebra classes that are like split up into little parts. So anyway, the point is you are higher than quite a few kids math-wise. And so if you're good at what we do here, you'd be really good at what they're doing, and you could be one of those people that helps. You don't have to be an NHS student. I know you usually aren't that until you're a junior or senior, but if you're just good at math, they would be happy to have you as a tutor in the math center. So some of you guys should think about that. All right, that's the end of that. But now we get into the lesson for today, and I asked you before if you could get that on your iPad, so hopefully you did. And let me see if I can find it here. There it is. Looks like this. And I'd like you to, I'm going to pause for a second while you turn it my way and show me that you have found this smartboard. I told you that one yet. But. All right, so here we are. This is properties of exponents. Basically, today is a review day because I pre-taught you this stuff. Remember when we got to fraction exponents? And it was like, oh, let's flip ahead a bit, like these kind of problems right here. Do you remember me showing you how the roots were on the bottom and all that? Okay, so today's going to just have one more little twist to that, but otherwise, I think I've got you understanding fraction exponents. We'll find out. So back to the beginning here. Let's just do a few of these really fast. What's that? X to the 5th. Good. What's this one? Careful with the 2 and the 5. 10x to the 5th. And some people think, how can those 2 and 5 mix together? Because one's on the x to the 3rd and the other's on the x squared. But it really is just like this. 2 times x to the 3rd times 5 times x squared. And the order when you're all multiplied doesn't matter. So you just rearrange them and you can put the 2 and the 5 next to each other and then it's going to be a 10. Okay, so that's why that works that way. These aren't like specially married to each other and these are specially married to each other. No, they're all just one big multiply problem. I won't try to extend the analogy any further than that. All right, that would be x to the what? X to the 12th. Good. The next one, x to the 3rd. You subtract them when they're like that. How about this? You still subtract them? Yes, you do. And it would be x to the what? Normally it'd be x to the -5th, but we don't write it that way. 1 over x to the 5th. Very good. And this one, 1 over x. Remember, negative means flip it. And power of 1 means stay the same. So stay the same and then flip it. Or flip it and then have it stay the same. All right, on to the next one. Flip it and cube it. 1 over x cubed. Why is that any better? Only because it doesn't have negative exponents in it. You're not allowed to leave answers with negative exponents. Negative exponents can be in the problem, but they can't be in the answer. Okay, on to the next one. That can be written as something to the something. And no, you can't cheat by saying 1/4 to the 1. No, 0.25 is not what we're looking for. It has to have an exponent. And no, 0.25 can't be put to the 1. So, 2. You could use 2. 2 to the what? -2nd. Now let's double check that. That's two things. It says, by putting a -2 there, it says square it and flip it. You get how that would be 1/4? Okay, but the problem is, that's using a negative exponent. I'm not supposed to leave it that way, am I? Oh, okay. So what's another way to do it? Because that one doesn't count. 1/2 to the what? To the 2nd. Is that written with an exponent? Is it a positive exponent? All right, then that's an okay way to do it. Yes? And yes, 1/4 to the 1st that's kind of cheating, but yes, that is another way to put it as a number to a power. But there's one more. Stretch yourself. Yes. That's what I have, though. There's another one like, okay. Oh, okay, okay. I get what you're saying. Like that. That is true, and but that's not the one I was looking for, but I can't really argue that it is different. So I'll give you a credit for that, but what else? There's another way to do it. I'll give you a hint. Go the other way. Don't use smaller numbers, use bigger numbers. What do you think? All right, so I'm going to leave, actually, hold on, undo that, I'm erasing. I'm going to leave that one up there, and then you're saying, all right, there you were on the right track, you just have one little thing missing, yes? 4 to the negative 1 is a true statement, but uses a negative power. Okay, come on, you can do this. Ooh, you got one, I can tell. Okay, wait a minute. 1/8 to the 1/2. Let me see if this works. What you're saying by doing that is the square root. And the square root of 8 isn't 4. There you go. Now you've got it. He corrected himself. I think this is it. Does that. Square root of 1 is 1, right? And the square root of 16 is 4. Isn't that the same as that? All right, that was a challenge one. Okay, on to this one. Rewrite it with an exponent. Yeah, you could say 16 to the 1 if you want to cheat, but there's 2 other ones. Yes, sir. 4 squared is a good one. That's 16, and it's using an exponent. What else you got? Yes. 2 to the 4th. That's the other one we were looking for. All right. There is actually a stretcher one that would also work. It's really tough. Starts with 32. 32 to the something. You got it? You can do it. It's not 32 to the 1/2 because that'll be the square root of 32, and the square root of 32 isn't 16. Say that again? 4/5. Nice. Because 1/5 root of 32 is 2, and then 2 to the 4th gives you the 16. That was a stretcher. We didn't even come up with that one in the other class, so nice work. Okay, on to this one. Do you remember, there's actually many ways to do this. If you can factor it, you should works. I just got to move the 16 over first. You remember that whole if you can factor it, you should? And what if you can't factor it? Answer this question. If you can factor it, what? You should. If you can't factor it, quadratic formula. Okay, so this one can factor though. Do you remember this factors into what? X plus 4 and x minus 4. Okay, and that means the 2 answers are 4 and negative 4. Does it ring a bell? Okay, but there's another way to do it, and this is important. Do you remember you can take the square root of both sides if you're careful about it? The square root of 16 is just 4. Don't think it's plus and minus 4. But the square root of x squared was special. Absolute value, good. And then that gives you 2 answers. X equals 4 and x equals negative 4. Remember how there's 2 answers for this? We just showed there was 2 answers before with the factoring thing. Okay, so the point is when you square root both sides, you get an absolute value. Try to remember that. But I bet 3/4 of you are going to forget it within the next 5 minutes. All right. So this definition of a rational exponent, a fraction exponent, is saying that if you have a fraction exponent, then you can make it into 2 parts, the square root and then the power, or you can make it the power first and then the square root part. Do you remember me saying which one was smarter? Which one should you do first, the power or the root? The root. Do the root first because you want to make it smaller before you make it bigger. So this is the way that's smarter because it makes you do the square root first, or the square root of the 3rd or the 4th root or whatever. And this is just another way to write it. That's like saying the square root first and then do that. But if you want to, you can do the power first and then do the square root. It's just showing you this in 2 different ways. All right, so back to these. You remember these? So we should do the root first. So let's just do these in our head real quick. What's the 3rd root of 8, and then you square it? What's the 3rd root of 8? 2, and then you square it? 4. Why don't you find the other 4 answers right now, and then compare them with the kids sitting next to you. I'll pause for a second while you try that. 4 more answers. Joe, you're first. fourth root of 16, and then you put it to the third, and you get, you are correct. Next one. Yes. Yes. 32. Raise your hand if you had 32 for that one. Okay, good. LF. Next one. 16. Raise your hand if you agree with her. Okay, good. Next one. WR. Raise your hand if you agree with WR. Okay, good. That's pretty much everybody. That's it. And you're good at that. Now, can you handle this? I want you to just think for a second. If the goal is to solve, that means get the x alone. What makes the x not alone? What's on the x? An exponent. How do you get rid of it? You just grab it, rip it off of there, and throw it away? No. To do something, you have to do some opposite somehow. What's that gonna do? What's the undoing of not the square root? You're warm. Put it to the power of 3 over 2. Now, that means this cancels this, that cancels that, and that becomes x to the 1, which is just x. And then you know how to do these, right? And we go square root of 4 is 2, 2 cubed is 8, and I knew it. You'd all forget it. I told you were going to forget it. Yes, sir? You needed an absolute value in there. Because you just did a square root to both sides, and you didn't even think about it. Isn't that sneaky and evil? You just square rooted both sides, but you didn't even think that you were square rooting, but you were. And then when you square root a variable, which this is, it needs to be absolute value of x. You get what just happened there? This square root right there, that's a square root. Remember, roots are on the bottom. You did a square root, and you forgot that that's absolute value. So x equals plus and minus 8 is your final answer. All right, I know it's kind of evil, but I told you were going to forget that. See how easy it is? On the test, I guarantee you, like half of you, by then will have gotten pretty good at this, and you'll catch it. But the other half are still going to miss that. They're going to be like, I'm just going fast, and I take the square root on both sides, and then they won't think they're taking the square root. Okay, how do I get this 3 off of there? Put it to the 1/3. Did I just take the square root or an odd root? An odd root. Now, this brings up an interesting point. Do I still need absolute values in odd roots? No, and here's why. Because when you're taking square roots, you have a negative in there, and it's going to cause trouble. You take a square root of a negative, and the world implodes, and we all die. So, we don't want to do that. But you can take the cube root of negatives. It just comes out to negative answer. -2. Do you get why cube roots are different than square roots? Can't do square roots of negatives, but you can do square roots or cube roots of negatives. It's not a problem. So I can do the cube root, and I don't need this to be an absolute value to force it to be positive, because we don't care if it's positive or not. So I know that's kind of complicated, and if it's too much for you, all you have to remember is this. If you do a fraction power to both sides, you are doing a root to both sides. But only the even ones are the kind where you need absolute values. If these numbers are odd like this, a 3 and a 3, if they're odd, it's an odd root. It's not a square root, and it doesn't need a plus and minus. Therefore, this one doesn't need a plus and minus. It's just 3. Any questions on that? All right, so if you do a fraction power, be careful, because half the time you need to do absolute value and they get 2 answers. The other half the time, when they're odd roots, you don't need absolute values, and you'll just get 1 answer. All right, so on this one, are you going to be doing an even root to both sides? No. In a way, you're sort of doing an odd root. Let me show you what I mean. Do you get how we're doing an odd root to both sides because it's 3 over 1? But an odd root doesn't cause a problem. It's only the even roots that have to be forced to be positive. So this does not need absolute value, and it's just x equals 3 to the 3rd, which is 27, and there you go. You getting the difference? Why didn't I need absolute values there? Because it was a what kind of root? Odd root. Will this one be an odd or an even root? It'll be an even root because when we flip it, the 2 will be on the bottom. But it brings up another one of my favorite sayings. It's not, if you can factor it, you should. It's get the clump alone. You haven't had enough problems like this for me to have said that in your class 8 million times, but we're about to have them. This clump here has to be alone before we can do that power thing to it. All the other ones, it already was alone. Now we're getting more complicated ones where the clump is not alone. So you have to get the clump alone. Good question. Then you got to combine all the clumps into one clump and get that clump alone. Get the clump alone. I need a thing on the shelf that I'm going to call a clump alone. So it just needs to be a really odd looking piece of ceramic, you know, artwork, and that'll be my clump alone. And I'll be like, get the clump alone. All right. So anyway, add 8 to both sides, and I get x to the 2/3 equals 9. Now that the clump is alone, now you do the same thing as we did before. Finish it. And then compare it to the people next to you and taunt them if they're wrong. I'll pause for a second while you begin the taunting process. That was just a joke, by the way, no taunting. Okay, here we go. Did you put it to the power of a even root? Yes, you did, because it's a 2 on the bottom, and therefore you better have 2 answers. Square root of 9 is 3. 3 squared, or 3 to the 3rd is 27, plus and minus 27. Who gets the gold star for knowing the plus and minus? Okay, good. On to the next one. Go ahead, get the clump alone. See if you can finish it. All right, I'm hearing some debate on whether or not this is going to have plus and minus or not, and I like it. I like you talking it over, because that's the thing you got. That's really the thing people mess up. It's really not that hard to do the first part. It's when I do this, am I doing an odd root or an even root? I'm doing an odd root, so I don't need the absolute values. If this number had been even, then I would. X equals what? The first root of 2 is just 2. 2 to the 4th, 16. There we go. Raise your hand if you had it right. Okay, good. And almost done here. Get the clump, which is this. This is the clump. That's why I call it a clump. A big clump of stuff. It's in a parentheses. Sometimes the parentheses doesn't show, but there's always a parentheses. Anyway, get that clump alone, and then do that same process to clear the power, and then we'll see if you know how to finish it. Some of you will, and some of you won't. Give it your best shot. I'll tell you how in a second, but some of you will know automatically just by your natural instincts. Okay, here it is. Add 7 to both sides. All of a sudden, this is a 27. Then I put it to the power of, flip it, 2/3. Oh, it's an odd power, so therefore I'm good. I don't need absolute values. Otherwise, if you thought this was an even power, do you get right here? You would need absolute values on that number. You'd need them here if we had done an even power root. But since it's odd, it's okay without them. And then this third root of 27 is 3. 3 squared is 9. Now we got to add 3 to both sides. 3x equals 12. I think I'm sensing a nice round number. Raise your hand if you had 4. Okay, good. On to the last, and almost last of that kind. You know what? We've practiced that kind enough. Oh, wait a minute. Ooh, this, no, wait. Flip it, and it's going to be, flip it, it'll still be an odd root, so it's no big deal. Let's try another one. Let's try this one. What? The square roots on both sides? How do I fix a square root? Ooh, interesting. Okay. So you're saying I should square both sides. What about the negative? How about if I wrote the problem differently for you, and let's see if this makes sense to you. Do you get this is the same exact thing as if I had 3x plus 2 in here to the power of what? Not negative 2. 1/2 means square root. The negative's still there. And this would be like 9x minus 10 to the power of what? 1/2. All I did is rewrite the problem. I didn't do anything except change it to be a fraction power. Does that make it more clear? You just got to square both sides? Okay, now, if I square both sides, that means like this. By squaring both sides, technically, it's got a 1 on the bottom, so it's an odd root, and I don't need absolute values. So, do you get when you square this, this negative is going to go away? Okay, so then 3x plus 2 is equal to 9x minus 10. And from there, I just got variables on both sides to get rid of the smaller one. Kind of a cruel world out there. They always take out the smaller one. What if you're small? Then you can hide. 12 equals 6x, x equals 2. Done. All right. Except the problem is, it doesn't work. Do you get how tempting it is to just like trust yourself and that, well, I did everything right, and it should be the answer? I'm going to tell you something about profiling. Profiling is something you don't want to do in the airport and only search people who are scary looking. Because what they'll do, if you think somebody's like really innocent, like grandma, you're going to like hide the nuclear device in grandma's wheelchair because you'd never search her. You can't do that when you're profiling in the airport because otherwise they'll just sneak it in somebody else's stuff. So, but you can profile in math. Most math problems work out just fine, but if they involve square roots, be suspicious. Because a lot of times when there's a square root involved, the answer you get doesn't actually work. Do you remember those kind? They're called something. It starts with an EX. Extraneous. Have I had to tell you about extraneous yet? Okay, this is your first time. So I get to tell you the finger story. I knew a guy who had an extraneous finger. Extraneous means it was an extra and it didn't work. He played cards and he'd have his hands out over the card table and he had the rare 6th finger. Do you know that that actually happens? I think it's polydactylism or something like that. Anyway, so he had an extra finger. He had a 6th finger hanging off of his hand, but it didn't work. Okay, it just kind of hung there. It wasn't actually connected with nerves and everything. And so just to mess with us, he would play with it like boing, 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 boing. So he'd be like boinging his finger, his 6th finger around. It's like, first of all, he's got 6 fingers, and now he's like boinging it. Anyway, I think it was a really good technique because I could not concentrate at all on the card game because he was like boing, 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 boing. So anyway, the extraneous finger, it's one that doesn't work. And by the way, just so you know, what usually happens in America, it is true, about 1 out of every 100,000 babies are born with a 6th finger that doesn't work. And it's an interesting dilemma if it does. Because if the 6th finger works, which can be true too, should you cut it off? That's the argument. Do you want to be the kid who's got 6 functional fingers at school? So you're kind of like more advanced than the rest of them, but at the same time they might hate you for that. And so anyway, it's an interesting dilemma. But they don't usually have to worry about it because the 6th finger usually doesn't work. So anyway, they just slice it off. So right now, I bet you a lot of you, your parents probably wouldn't even tell you, hey, by the way, you had 6 fingers when you were born, because they'd barely think you were feel like, oh, dude, I guess that was weird when I was born. So if you look for a little scar right here, if you've got a little scar right here or right here, and you can't explain why, then you might have been the 6-fingered child. You could be in a James Bond movie. There was was it Goldfinger? I think it was, anyway, one of those James Bond movies, the bad guy had 6 fingers. Anyway, yes, I know, it's okay. Oh, That'll work well for them in card games. Okay. So the moral of the story is that when you get answers for things that have square roots, you have to watch out for extraneous answers. And if you get an answer that doesn't actually work, you can tell because you stick the 2 back in, and it seems like whenever you do this on things that work, you get the right answer, but in this case, it doesn't actually work. This does not come out the same as that, and therefore they're not equal, and therefore it does not work. So when you check your answers, which you should, anytime there's a square root involved, check it, double check it. You don't have to check every single answer in the test. Just profile and only check the ones that have square roots, because those are the ones that are the ones where this happens. Okay, so again, like I said, it wouldn't work at the airports and stuff. That is a bad place to profile. But in math, we can do it on square roots because it's the most common place you have to worry about. Cancel it off and write EXT. Everybody do that right now to remind yourself. That's what you do on problems that don't work. It's called extraneous. It means it's kind of like, you know, that little thing hanging off his hand. That was a finger, but it didn't really work. Okay, well, this is an answer. It's an answer you got the right way, but it doesn't really work. That's what an extraneous answer is. That's different than no solution. No solution means it was impossible to get any answer. This means I got an answer. It's just that the answer doesn't actually work. So it's a new thing for you. You're going to see it a lot in pre-calc, extraneous. All right, moving on to this guy. Base change. Can I get that 16 to turn into something with a 2? Yeah, 2 to the what? There you go. And now that the bases are the same, that equals that, and it's no big deal. Okay, so also from yesterday, a little bit more complicated one. Do you get, I can make both of these into 2 to the something? That can be 2 to the something, and so can that. And once the bases are the same, you're good. But couldn't you also make them into 1/4 to the something? Yeah, you can have more than one choice, but as long as you make the bases the same, I'm going to choose to leave this one alone, and this one into 1/4 to the second. Now the bases are the same, and thus that equals that. All right. So I think that's enough review of yesterday. We already practiced those a ton. Your homework is, because we have very little time to work on it, I'm giving you just the evens, just in case there's multiple letters, like problem number 1 has A, B, C, D, E, F, G. It's even problems and even letters. If you're not used to that, because you didn't have me first semester, even letters are B, D, and F. B, D, and F. So in other words, if you're supposed to do the evens, and it has a whole bunch of parts, you don't get to skip problem 2 if it's got A, B, C, D, E, F, G, H, I. You get to only do the even parts. The even letters are B and D and F, etc. Okay, and that's all I've got for you for today.